We're going to continue talking about oxidation states. And let's remember what is oxidation and what is reduction. So say that you have sodium, the metal, and we know that it has 1 valence electrons. So if sodium goes and forms sodium metallic by losing 1 electron, we say the sodium is being oxidized. So this is an oxidation. And in oxidation, we lose electrons. Now say that I know that chlorine is a gas, is a diatomic molecule, but say that we're forming chloride, and I need to put a 2 to balance for charge. And I will need 2 electrons here. But notice that here the oxidation state of chlorine, the pure element, is 0, and it, as simple ions, the oxidation state equals the charge. So chlorine is going from 0 to -1. So it is decreasing its oxidation state. So it is a reduction. So again, oxidation state, oxidation number increases. So here is going from 0 to +1, increasing. And here the oxidation number is decreasing from 0 to -1. And let's look again at our series of molecules, of organic molecules. We did before methane. And in methane, to do it, faster, we say that the oxidation state was 4 valence electron minus. Remember that we now consider the bonds, now the electrons in bonds assigned to the more electronegative atoms. So this 2 will go to carbon, this 2, and this 2. So oxidation state here will be 4 minus 8, so it's -4. And in this series, we said that we're going to replace 1 hydrogen by an oxygen. And then when we do the math, oxidation state, valence electrons is 4. And then we look at how the electrons are assigned. Here, these 2 electrons are going to go with oxygen. But this between carbon and hydrogen, carbon is more electronegative, so it's going to take it. Same here, same here. And when we do the math, then we say 4 valence electrons minus, and we count 2, 4, and 6. And the oxidation state here is -2. So what's happened when we go from here to here? The oxidation number has, now notice, changed from -4 to -2. So it has increased. So this, in going from here to here, we have an oxidation. And to remember how this goes, see that numbers. If this is my 0, 1, 2, 3, my real numbers. This is -1, -2, say -3. Anything, if you're going to the right, is going to be increasing oxidation number. Here, sodium went from 0 to +1. That was an oxidation. And when we did chlorine, went from 0 to -1. So went to the left. So it is reduction. What we just did with carbon, well, now carbon went from -4, so I need to extend this line a little bit. -4. And now it goes from -4 here to -2. Notice now the oxidation number has increased. So in this direction, and this might be confusing with what I wrote before. Again, if you're increasing the oxidation number, this is what I represented here is the sodium. From 0 to +1. Increasing, so going to the right, is oxidation. So this direction is oxidation. Increasing oxidation numbers. If I go the opposite way, so to the left, I am decreasing the oxidation number. So it is a reduction. And what we just did for carbon, we went from -4 to -2. So it is increasing. We're going to the right there. So the carbon is being oxidized. Let's do one more. Now let's say that, and I have another compound here. And here it is. So in this compound, let's do the oxidation state. Oxygen is more electronegative than carbon, so it's going to take all those 4 electrons there. And now, between carbon and hydrogen, carbon is more electronegative, so we're going to do this. In doing the math, will be 4 valence electrons, and I might subtract the electrons assigned to carbon. And I had 2 and 2 is 4. So oxidation state here is 0. So let's see, is that an oxidation or a reduction? Well, now we're going to go to here, my ruler. So the oxidation number has gone from, say that we're going from here to here, right? Let's see that analysis. So from -2 to 0. So here I am from -2 to 0. I'm going to the right. So that is an oxidation. The oxidation number has increased. So we're going to do more of those examples. The more complex molecules that may have several carbons, and those can have different oxidation states.